Okay, today in IM2 we're going to study the properties of parallelograms. And they have a lot of specific properties, so you want to be familiar with them. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. This is the definition of a parallelogram. So if you're ever going to use the definition in a proof, it's only to identify that both pairs of opposite sides are parallel. Okay, the other facts will be based on theorems, and those are what comes next. Okay, so the parallelogram opposite side theorem states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So this is true for squares, and it's true for rectangles, and it's true for rhombuses, because those are all parallelograms. Okay? The parallelogram opposite angle theorem states that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So this one is congruent to this one is congruent to that one. Okay, and again, that applies to those because they are also parallelograms. Okay, so here is the proof of the parallelogram opposite side theorem. So again, I'm going to ask you to pause and read through this and follow the logical thinking of each one of these to see if you can see how it progresses. If you have any questions, you can ask me. But here's the thing you need to remember. When you are proving a theorem, you cannot use the theorem you're trying to prove. So you have to attack the proof with other theorems and postulates. So take a look and see how they did this one. When you're ready, you can push go again. Okay, so using the properties of parallelograms, we're going to find the values of x and y. So first thing I notice is that they've identified it as a parallelogram, okay, with those symbols that they have on all four sides. So by definition, I know that it's parallel. They told me it was, but even if they hadn't told me this was a parallelogram, those little symbols tell me it is. So I'm going to use the parallelogram opposite side theorem. And I'm going to use the opposite side theorem. I could solve for y or x first, but I'm going to solve for x first. So the opposite side theorem says that the opposite sides are congruent. So x plus 4 equals 12, x equals 8. There's 1. And then we know that this angle is equal to this angle. So y equals 65 degrees. So that was pretty easy. And that's by the parallelogram opposite angle theorem. Okay, opposite side theorem. And you don't want to just call these that. You want to call them the parallelogram opposite side or angle theorem. Okay, so now we have another rule for parallelograms. Parallelogram consecutive angle theorem. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. That means the ones next to each other. These are consecutive. They are supplemental. Or these are consecutive. Or these are consecutive, and these are consecutive. So you can see that in each case, x plus y equals 180. And they are supplementary. Okay? Then there's the parallelogram diagonals theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Notice that QS bisects RP into these two equal sections. Okay, so just remember what that means. Okay, again, here's a proof for you to look at. This is the parallelogram diagonals theorem. So notice what they give you, and then you have to prove that M bisects QS. So I'm going to leave you, push pause, and look through this. Make sure you understand the reasoning, and then we can move on when you're ready. Okay, so using these theorems that we just learned, we've got the parallelogram opposite side and opposite angle. They want us to find the value of x and y in each of these pictures. Now, the first thing I noticed is that if I tried to use the side theorem again, I have an x and a y. But if I do the opposite angle one, I have just an x. So I'm going to go ahead and do the opposite angle first. The parallelogram opposite angle theorem, I'm going to use that first, equals 49. I'm going to add 37 to both sides. I get 4x equals 86. Divide by 4, x equals 21.5. If you want to make sure that works, just plug it back in, multiply it by 4, subtract 37, and it works. Now that I've got that x, I can solve for this equation. So I'm going to go 4 times 21.5 minus 3. And 4 times 21.5 is 86, minus 3 is 83. So that is this side, 83. So that means that y over 5 equals 83. So I just multiply both sides by 5, and I get a great big number for y. Y equals 415. So there's my two answers. We can check them right there, and we're good to go. Okay, over here we can see that both diagonals are only one variable, so we can use either one. We're going to use the parallelogram diagonals theorem here. So we can say 5y minus 16 equals 3y. I'm going to add 16 over to this side, and I'm going to subtract 3y. So I get 2y equals 16, y equals 8. Okay, you can go back and plug it in, see if it works. And then I get 2x, because the other diagonal is cut in half as well, so they are equal. 4x minus 2. Subtract 2x from each side. I get 2x. Add 2 to both sides. I get 12. So x equals 6. And again, check your answers by plugging in. So make sure you know which proof you're using. That will help you. Sometimes you're asked, which proof did you use? Okay, so using the properties of a parallelogram. As shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find angle BCD, so BCD, that's this angle here, when angle ADC, that's this angle here, is 110. Well, the first thing I know is that those are consecutive angles, so I'm going to use the parallelogram consecutive angle theorem. And I know that the measure of angle, because of that theorem, I know that the measure of BCD plus the measure of ADC equals 180 because they're supplementary. So I'm just going to substitute 110 for the measure of ADC. Then I'm going to subtract 110. And I get the measure of angle BCD equals 70 degrees. Okay, so you just have to look at the parallelogram. Which rule am I applying this time? And then you can work it out. Now we're going to use parallelograms in the coordinate plane. So you can see that I've already graphed the coordinates that they gave us for the diagonals of LM and O. Make sure that you remember to put them in order, LM and O. And they want to know what is the coordinates of the intersection, so of the diagonals. So where do they intersect? Okay, and I definitely didn't use a ruler. So what we need to remember is that using the parallelogram diagonals theorem, we know that these are congruent. Okay, so that tells me that this is a midpoint. So I can use the midpoint theorem. But remember, you're finding the midpoint between L and N, or M and O. Okay, so what I did was I did M and O, and so I used the midpoint formula, and I did 7 plus 0 divided by 2, and 4 plus 0 divided by 2, and that gives me a midpoint of 7 over 2, which is 3.5, 2. Okay, so you could write it either way. Now, this tells me that midpoint, and I can check it by graphing it and looking at that. And so I go to 3.5 and 2, and there's my midpoint. Okay, so checking it is really hard once you get a fraction, so be careful with that. Okay, here's another one on the coordinate plane. Okay, so in this example on the coordinate planes, they give us 3 vertices of a parallelogram. Now it's really important when you're working with things on the coordinate plane to remember that the name of the polygon gives the order of the vertices. So we have parallelogram WXYZ. That means there is a missing point right here. So you have to remember that there is a point that's probably going to end up in that quadrant. So what kind of information can we use to remember how to do this? Well, I know that WX, by definition of a parallelogram, is parallel to YZ, and XY is parallel to WZ. So I'm going to use that information, and I'm going to start by finding the slope of XY, or WX. Okay, so I'm going to use the 2 points that I was given, 2 minus negative 3 over negative 3 minus negative 1. And I zip-zap that, I get 5. I zip-zap that, I get negative 2. So now that I know that that's the slope of WX, okay, I could count it here too. You could do it the same way. I like using the slope formula. But I also know that it's the slope of WZ. So I could actually remember rise over run. And I could just go rise, 2, 3, 4, 5, run of 1, 2. And there's my y. Okay, so that's y right there. And then I could double check by just quickly drawing on the diagram and say that the slope of this one is 1 over 1, 2, 3, 4, 5. The slope of WZ is negative 1/5. And so I could check 1, 1, 2, 3, 4, 5, and I find that the slope of XY is also negative 1/5, so I have verified my point. And here's how they did it in the book. They did that again, they verified it, and you can see that they did the point formula, the slope formula to find the slope of those two to double check, but they used the rise and the run to graph it. So there you go for today. We learned a lot of rules about parallelograms. Go through and remember all of them. Good luck.